Hello all and welcome back. I'm yet to see a programmer who can write flawless code. And when I say flawless code, I just don't mean message box hello world. No, I don't mean that. I strongly believe that writing good code can take you to the different places of this beautiful world. Not only geographical regions, but different corners of the web world, considering work from home is also an option. Way back in 2005, I met a lady while answering questions in, I think it was expertexchange.com. And she said something which stuck with me for a very long time. And it is, you're never too old to learn and you're never too young to teach. This hit me real hard. Not that I didn't know about this. I knew about this, but I didn't know there was a phrase for it. So like I said, it hit me real hard. It made me stop because I used to think I write amazing code. So I stopped and I was flooded with different questions. The first one was, do I actually write good code? Is there nothing else to learn? Is there no way an error can happen in my code? And if it happens, how will my code react? Have I covered every possible scenario that my code will come across? Can I recognize my code if I looked at it, let's say, after 6 months? And many more questions. To my surprise, I had vague answers. Surprised? Even I was. Writing good code is not rocket science. It is similar to cooking your favorite meal or painting, if I may say so. There are some of the few things that you need to take care while coding. Let's take a look at them one by one. Wow, wish it was that easy. Snap your fingers or wave a wand and the code suddenly appears. But hey, come on, let's face it. We are not magicians. We are more like architects. Before constructing a building, an architect must draw a plan of the building, which is also referred to as a blueprint. Based on the blueprint, the building is then built meticulously. Architects must think of many things before they draw up a plan for a building. First, they must think about what the building will be used for, how many people are going to use the building at the same time, what types of activities will people do in this building, etc. Same is the approach that we need to take when we write code or build an application. The idea of writing a code or developing an application always excites me. My favorite way to create a blueprint is to take a notepad and jot everything that comes to my mind. I've noticed in the past that the first thing that happens to me when I pick up a notepad is that I get swarmed by ideas and thoughts. However, that doesn't bother me. I ensure that I jot all of them down. Once I feel composed and more focused, I revisit my notes. This is the moment when I usually have a faint idea on how my application looks like. For example, let's assume that we need to develop an application for ourselves. The mere fact that we are developing something for ourselves can be very exciting. Let's say we need to develop an application for a mini home library. Once you do the exercise that I mentioned above, your notepad might look something like this. Now, based on the application that you're developing or the code that you're writing, you might have to revisit the notepad many times. That's absolutely fine. During these many times, you will edit your notes or you might strike out some of them. That's also okay. As the time goes by, you will notice that your thoughts about the application are more structured. The faint image which you had earlier about your application now becomes more and more prominent. Once you finally see the complete and clear image of your application, you are now ready to construct your building. Writing your code. Let's move on to the next important thing. When we start coding, the very first thing that we need to do is declare option explicit on the top of the code. If you look at my Visual Basic editor, you will see that I have option explicit on the top. I've spoken about option explicit in detail in my video Introduction to Visual Basic Editor. In that video, I've shown how to ensure that option explicit appears automatically when you open the Visual Basic Editor. So if you have not seen that video, then I highly recommend watching that video. Let me do a quick recap on how to ensure that the option explicit appears automatically when you open the Visual Basic Editor. Click on Tools, then click on Options, and in the first tab, which is Editor, ensure Require Variable Declaration is checked. I obviously have it checked, and that's the reason why you can see option explicit on the top of my code. Once you check this option, click on OK. Now, why is declaring option explicit so important? There are two main reasons for using option explicit. First, it forces you to declare your variables as a specific data type. Now, Visual Basic defaults the variable to being type variant. A variant type of variable can hold any kind of data from strings to integer, to long integers, to dates, to currency, etc. By default, variants are the slowest type of variables. So if you want to store a number with decimals, then you might want to declare it as a double, or let's say currency. For example, if I want to store my height in a variable, I would do it like this. So what I've done here is I have declared my variable as double. If you look at the variable above that, which is last row, I have declared it as long. The second main reason for using option explicit is that it keeps a watch on your code, checking for spelling mistake that might happen when you type your variable. Let's take an example. I'm going to delete this code, okay, and then I'm going to type some fresh code. In this example, we will try to calculate mass of an object. But before that, let's comment the option explicit because I want to demonstrate something to you. Here I have set the value of density to 3 and the volume to 4. Here I am multiplying density with volume to find the mass. Now let's go ahead and let's try to run this procedure. But before you run this procedure, ensure your cursor is inside the procedure, and then you click on the Run Sub User Form button, or you can also press the shortcut key F5. And we get the mass is, but there is no value after that. I was expecting to see 12 because 4 multiplied by 3 is 12. We did not get any error, nor did we get any alert. So what could be the reason that we did not get the value? The reason is very simple. So I'm going to click on OK so that we can go back to the code. Now look at this line. Can you identify what's wrong with this line? If you're able to, then that's really awesome. Give yourself a pat in the back. If you did not, then let me explain it. Here we have declared a variable for mass and we have spelled it as MASS. However, when we are displaying the value, I deliberately made a spelling mistake. So there is one S which is missing here, and hence we did not get the correct result. What would have happened if we had option explicit on top? Let's uncomment this and then let's run the procedure again. Let's see what happens. See, option explicit always ensures that an error alert is displayed to make you aware of what went wrong. So here it is clear to us that the variable has not been defined. So you will immediately realize, oh, that's a spelling mistake. So let's go ahead and let's fix it. I'm going to click on OK. I'm going to stop the code. Then I will type S here. Okay. Now I'm going to run the procedure again. There you go. We get the correct result. So remember to always use option explicit. Moving on to the next topic. Now, variables are containers which hold values that are used in your code. It is essential that you give them appropriate names and declare them correctly. If you look at this procedure, I have calculate mass. Also look at the names of the variables. Just by looking at the names, you can guess what kind of data they will hold. What if I change this code a little bit? I'll change this to sample. I'll make this M, D, and V. Similarly, this becomes D, V, M, D, V and M. Okay, so this is the change that we made. If you run this code, you get 12, which is fine. So technically, there's nothing wrong with this code. You already now know what this code is doing, but imagine if you are looking at this code for the first time. By simply looking at it, can you make out what this code does? I'm sure you can't. There are three things that I would like to draw your attention to. First, give your procedure a meaningful name. Since we are calculating mass, let's give it a proper name. So this will be calculate mass. This will ensure that if you're skimming through your code looking for something in particular, just by looking at the procedure name, you can decide whether you want to inspect the code within that procedure or not. So always give your procedure appropriate names so you know what the procedure is all about. Just like you gave your procedure meaningful names, simply give your variables a meaningful name as well. This will ensure that you don't end up confusing yourself later whether D should be multiplied by V or should it be multiplied by M, as you wouldn't know which variable is doing what exactly is it for. So naming them meaningfully will make your life easier as you know what that variable is supposed to do. And lastly, well, I already mentioned this, but I will mention it once again. Always declare the type of the variable. As I mentioned earlier, if you do not specify the type of the variable, VB defaults the variable to being type variant. And you wouldn't want that, as it would slow down your code, as the VB compiler takes time to decide on what kind of variable you're using. Variants should also be avoided as they are responsible for causing type mismatch errors. It's not that we should never use variants. They should only be used if you're unsure what they might hold during code execution. Okay, moving on. Okay, so what exactly is indenting and why is indenting your code so important? Let's check out the code in module 2. By looking at this code, you will realize it is not clearly readable. So indenting basically helps you in making the code readable. Try digging up an old code that you wrote which is not indented. You will notice that you will have a tough time following the logic of the code. Indenting also helps you in inspecting separate chunks of code. This is important if you're trying to find errors. The most common error that you might face is missing levels of nesting or loops. For example, this code is missing a line. Can you tell me which line am I missing? I'm sure you will take some time to find it out. If you indent the code, then it will be easier to find the missing line. Indenting also helps you in maintaining the code. Coding is based on logic and logic can change. The best way to check this is to pick up a code which you wrote several years back. I'm sure that you will realize that the same code could have been written in a different way. If your code is indented, then it is easier to update the relevant sections of the code. Indentation by default is not a requirement of most programming languages, but it is wise to indent your code. Let me first insert the missing line. Now let's go ahead and indent the code. I use MZ tools, which is not free. You can use RubberDuck or any other tools which are free. So I'm going to indent it. See how the code looks neat after you indent it. Every loop, every if and if is now clearly visible. Moving on to the next important thing. If I dig up a code that I wrote few days back, I will have no problems in following the logic of the code if the code is indented. But if I inspect a code which I wrote couple of years back, which is indented, I will take some time to understand the logic. Now, let's look at this piece of code. Here, it's exactly the same code which we have in module 1, but the only difference is that this code is indented. Now, how much time do you think you will take to understand what this code does? Inserting comments like indentation is not a requirement. But yes, I can tell you from experience that in the future, you wouldn't want to spend half a day trying to figure out what some function or procedure did and why you used it in a certain way. So Remember, always indent the code. The next thing that I want to talk to you about is writing short and sweet code, if I may say so. The longer your code is, the longer will be the execution time. And not to mention the time you would take to understand what it does. What can be written in few lines shouldn't take 50 lines. You can write precise code by avoiding duplicate code segments. There are some scenarios where you use same lines of code again and again. Let's take an example. Let's go to module 3. Here I have two set of codes which basically do the same thing. Let's go to sheet for the moment. Here I have density, here I have volume. Here I want mass to be calculated. So the mass in this column will be 10 multiplied by 1, 10, 10 multiplied by 6, 60, and then we have 6, 6, and 30. So this is the output that I want here. Let's go back to the code. So in this procedure, what I'm doing is I'm storing the value of density from A2, then I'm storing the value of volume from B2, then I'm multiplying density by volume, and then I'm writing the mass to C2. Similarly, I'm doing that for the third row, fourth row, fifth row, and sixth row. Let's go ahead and let's run this. Okay, let's go back to the worksheet and you will see that the values have been populated. What I'm going to do is I'm going to copy these values and I'll paste it here. Then I will clear this off. The reason why I'm doing this is because when I run the second procedure, I want to compare the values with these values. Okay, so let's go back to the code and let's run the second procedure. Okay, let's go back to the worksheet and you will see that I get the same result. So what I have done here is instead of duplicating the code, I've utilized a loop to optimize the above code which does the same thing. By the way, I've spoken about different kind of loops in detail in my video 5 loops. So if you have not seen that video as well, then I highly recommend watching that video too. You can also write precise code by removing the unnecessary lines of code. For example, let's go to module 4. See these two codes? They both do the same thing. You usually get the first kind of code when you are recording a macro. See this line. Here we are activating the worksheet. Then see this line. Here we are selecting the worksheet before writing to it. Or look at these lines. These are recorded when you scroll down on a worksheet. The macro recorder records almost each and every step. We do not need these for the final macro to run. One should also avoid using .select, .activate, selection, active cell, active sheet, active workbook, etc. Two main reasons why these should be avoided. First, it slows down your code. Second, it is usually the main cause of runtime errors. So always declare your objects and work with the objects instead of using selection, .activate, active cell, etc. Now look at the second code. This code does the same thing what the above code does, but I have removed lines like active window, .scroll low, etc. We don't need that. Also see how I have avoided using .select and .activate. If you wish, you can pause the video to compare the code. I've also given the link to this workbook in the description below in case you want to open and compare the codes. The next important thing that I would like to cover is error handling. You should know what your code is supposed to do and under which circumstances it could fail. Now, it is genuinely not possible to account for every such instances where your code could fail. But for that, we must ensure that we handle all possible future errors proactively. Errors can pop up from any corner of your code. A line which you thought could never fail suddenly throws an error on your face. Let's check out a simple yet interesting example. This code creates an instance of IE and then navigates to a particular site. Let's run this. And the code works. Now what can go wrong with this code? Nothing, right? Well, not quite right. What if I distributed this code to a user who uses Microsoft Windows but doesn't like Internet Explorer. He went to the extent of, let's say, uninstalling IE from his PC. Which browser he uses is immaterial at the moment, but the very fact that he doesn't have IE on his PC will crash this code. So how do we handle such kind of errors? Now look at the procedure below. This code does the same thing as the above procedure. The only difference is there is proper handling in this procedure. When the user runs this code, the code will check if IE exists. If IE exists, then it will create an instance of IE and display the relevant website. And if IE doesn't exist, then it will simply inform the user about the problem and then exit the code gracefully without crashing the code. I have covered error handling in detail in my video, Error Handling and Debugging. The video is in 2 parts, so go ahead and watch that video to understand the concept of error handling. Moving on, the next thing that I want to cover is about automating other applications. While building applications, sometimes we need to automate other applications. For example, we just tried automating IE. If you browse the web, you will realize that it is an ongoing debate on which binding, early or late, one should follow. Personally, I'm more inclined towards late binding. So what exactly is late binding and early binding? Late binding uses create object to create an instance of the application object which you can then control. To use early binding, you first need to set a reference in your project from the Tools menu, and then you click on References, and then you set a reference from here. The biggest drawback of early binding is that the end user might not have the same application which you have on your PC. For example, if your application early binds with, let's say, Excel 2003, for that the user has to set a reference to Microsoft Excel 11.0 object library. Then that code will not run on a PC which have, let's say, Microsoft Excel 2007, which is the Microsoft Excel 12.0 object library. Or similarly, if this system has, let's say, Excel 2010, this can cause a lot of frustration to the end user. In such cases, it is always preferable to use late binding. Early binding has its own advantages as well. For example, the use of IntelliSense, full access to the application's object model via the object browser, VBA help, faster compilation, etc. So you will have to make that choice whether you want to use the early binding or you want to use the late binding. The most common technique that people use is they write the code in early binding and then they convert that to late binding. So you can do that as well. Okay, moving on to the next topic. I have something which is called an avoid list. I'm sure even you do. My avoid list contains few things. For example, avoid shortcuts or hacks. Writing precise code is different than writing hacks or shortcodes. Shortcodes or hacks are basically temporary adjustments made in the code so that it can run without giving any errors. This should be completely avoided as they are not reliable. Second, avoid complex codes. Complex codes can be of 2 types: sophisticated code and confusing codes. Now, sophisticated programming style is often used by advanced programmers. This style is often looked down upon by various programmers because this style has been misused quite often to project one's superiority. Till the time one refrains from such childish acts, I see no harm with this style. One should also refrain from this style when you're working in a team in an organization. This ensures that the code can be maintained effortlessly even when you are long gone. And if you need to use this style while working in a team, then please ensure that you comment the code. Confusing codes are complex codes which not only confuses the developer who's inspecting it, but also the developer who created it. This usually happens when the logic on which the code is based is not very sound, or the code is not well commented or indented. So try and avoid complex codes. Keep it simple. Third, avoid unnecessary dependencies. Using third-party components in your code or application which the end user has no access to will certainly cause problems. If there is no alternative, then get the necessary rights if the third-party component is a commercial product to distribute it with your application. Develop an installer to deploy it in the end user PC. And yes, keep the end user in the loop. The final thing in my avoid list is avoid assumptions. This might sound funny to you, but while programming, consider the end user as a newbie, even if the end user is an expert. And that is because the end user will never behave like you would expect them to. Like I mentioned earlier, extensively plan your code and ensure that appropriate error handling has been taken care of. And the final topic. Test your code extensively before distributing your code or the application. It's very frustrating for the end user if the code or the application crashes, leaving them high and dry. Think of the time, energy, and the potential data loss that can happen when the code or the application crashes. First thing first, always compile your code. You can do that by clicking on debug and then clicking on compile VBA project. And if you have also included error handling, then your code will not crash. You will get appropriate error messages. So this is my list. If you do have a list of your own, please do share. I would definitely like to know what you consider best practice, and it may also help other viewers. Time for a quick recap. In this video, I shared 10 different things that can help you write good code. If you still have any questions, feel free to leave a comment in the comment section below, or you can also email me on support@tamexcel.com. Keep those emails coming. I love answering your emails. Alternatively, you can also join the Facebook group. The link is in the description below. Feel free to post a question there and I'll be more than happy to answer your questions. If you like the kind of content that I'm putting up on this channel, and if you would like to extend support, then go ahead, watch a couple of videos, drop a couple of likes, share the contents that you like. And if you're seriously, inclined to learn Visual Basic Programming from scratch, then go ahead and watch the playlist, because that is where I have arranged the videos in a specific sequence. So yes, go ahead and watch those videos, drop a couple of likes there as well, and I will see you soon in my next video.